Today we're going to be focusing on density. It's a presentation that was adapted by Science Doodles. Make sure you have your density foldable out and ready to take notes on. Density is defined as the ratio between mass per unit of volume. Specifically, density, represented by a D, is mass, represented by an M, divided by volume, represented by a V. So mass is always in our numerator on top. The volume is always in our denominator on the bottom. When we measure density, mass is always going to be represented in grams. But volume will have a different representation depending on if you are representing a solid, a liquid, or a gas. Solids are always represented with grams over cubic centimeters. We can't pour a solid into a graduated cylinder to measure it. We have to find the volume a different way. Thus, it is represented in a different way. Volume of a solid object is always cubic centimeters. So density will always be grams over cubic centimeters. Liquids and gas, on the other hand, are both grams per milliliter. So let's dive more into density and what makes up the density. What is mass? How we determine it? Well, mass is the amount of matter in an object. It's all those little teeny particles packed tightly into one object. To find the mass of an object, we would place that object on a balance or a scale, and then we record the mass in grams. For instance, I might put a pack of index cards on a scale and find that the mass is 151 grams. Volume, on the other hand, is not all the matter that makes up that object, but instead the amount of space an object takes up. When we think about that graduated cylinder and we pour water in it, the water is now taking up all that space in our graduated cylinder. Once we reach the top of the graduated cylinder, there's no more space. We can't put anything else in it. So the volume is the amount of space that that water takes up. To find the volume of a liquid, we would pour the liquid into a graduated cylinder. Could be a beaker, could be a measuring cup. We want to get on eye level, which means all the way down so we could see the graduated lines. And then we want to record or write down that measurement in milliliters. If we want to find the volume of a rectangular object, we have to do it differently. We can't pour a cube into a graduated cylinder. So we have to find it by multiplying the length times the width times the height. So the volume of the cube represented would be length times width times height. One thing to remember is you can only use this formula for a regular shaped object, something that has a defined length, a defined width, and a defined height. And finally, if we want to find the volume of an irregular object, an object that doesn't have a normal, easy to measure shape, we have to use something called water displacement. Our first beaker has 50 milliliters of water in it. And it might surprise you that the second beaker also has 50 milliliters of water in it. We didn't change the amount of water, but what we did was displace that water. We added something with volume into the beaker, which made the water have to move out of the way. So our beaker in the end has 75 milliliters showing in it. If we took out that 50 milliliters of water, we would have the difference left of 25 milliliters, which would be our object. This irregular shaped object looks a little bit like a rock. Another way to remember it is you can take the water with the item in it subtract the water without the item. That's again like taking the water out, and it will leave you with the volume of the item. And as always, we cite our sources. Density Doodle, Scott Information.